Arc fault circuit interrupter, or AFCI, breakers are designed to protect against electrical fires. They do this by detecting arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur when there is a break in the insulation of a wire or when there is a loose connection. When an AFCI breaker detects an arc fault, it will trip, cutting off the power to the circuit and preventing a fire. AFCI breakers also have a feature called parallel tripping. This feature allows them to trip other AFCI breakers on the same busbar if they detect a ground fault. A ground fault is an unintentional electrical path between a live conductor and ground. Ground faults can occur when there is a break in the insulation of a wire or when there is a short circuit. When an AFCI breaker detects a ground fault, it will trip all of the AFCI breakers on the same busbar. This is a safety feature designed to prevent electrical fires by cutting off power to all circuits in the event of a ground fault. In the situation presented, the trim crew had placed two AFCI breakers on opposite sides of a panel on the same busbar. The ground wire of a receptacle was connected to the hot side, causing a ground fault. When the first AFCI breaker was turned on, it detected the ground fault on the other circuit and tripped. When the second AFCI breaker was turned on, it also detected the ground fault and tripped, cutting off power to both circuits. This is a good example of how AFCI breakers can help to prevent electrical fires. By detecting ground faults and tripping all circuits on the same busbar, AFCI breakers can help to prevent fires from starting in the first place. To understand how AFCI breakers work, it's important to understand the different types of faults they are designed to detect. Firstly, there are arc faults, which are unintentional electrical discharges between two or more conductors. These can occur due to damaged wiring, loose connections, or faulty appliances. Secondly, ground faults occur when a live conductor comes into contact with a grounded surface. This can happen due to damaged insulation or faulty equipment. AFCI breakers use sophisticated electronics to detect these faults. They monitor the current flowing through the circuit and look for unusual patterns that indicate an arc fault or a ground fault. When a fault is detected, the breaker trips, interrupting the flow of electricity and preventing a potential fire. The parallel tripping feature is an additional safety measure that enhances the effectiveness of AFCI breakers. When one AFCI breaker detects a ground fault, it sends a signal to the other AFCI breakers on the same busbar, causing them to trip as well. This ensures that the entire circuit is de-energized, reducing the risk of a fire spreading to other areas. In the specific scenario described, the incorrect wiring of the receptacle created a ground fault. The ground wire, which should be connected to the grounding system, was instead connected to the hot side of the circuit. This caused current to flow through the grounding system, which is a sign of a ground fault. When the AFCI breakers detected this ground fault, they tripped, protecting the circuit from a potential fire. It's important to note that AFCI breakers are not a replacement for proper wiring practices. They are a safety device that is designed to protect against electrical fires, but they will not prevent all fires. It's still important to ensure that all wiring is installed correctly and that all electrical equipment is properly maintained. Here are some additional points to consider regarding AFCI breakers and their operation. Firstly, AFCI breakers are required by the National Electrical Code, or NEC, in many areas of the home, including bedrooms, living rooms, and dining rooms. Secondly, there are two types of AFCI breakers: combination AFCI breakers, which protect against both arc faults and ground faults, and branch/feeder AFCI breakers, which only protect against arc faults. Thirdly, AFCI breakers can be sensitive to nuisance tripping, which is when they trip for no apparent reason. This can be caused by faulty appliances or by electrical noise in the circuit. Fourthly, if an AFCI breaker trips frequently, it's important to have a qualified electrician inspect the circuit to determine the cause of the tripping. Fifthly, AFCI breakers should be tested monthly to ensure that they are working properly. This can be done by pressing the test button on the breaker. Sixthly, if an AFCI breaker fails to trip when tested, it should be replaced immediately. Seventhly, AFCI breakers are an important safety device that can help to prevent electrical fires. By understanding how they work and by following proper wiring practices, you can help to keep your home safe from electrical hazards. Eighthly, the parallel trip functionality is a crucial component of AFCI breaker systems, especially in residential settings where multiple circuits may share a common busbar within the electrical panel. This coordinated tripping action ensures that a ground fault on one circuit doesn't remain isolated and potentially escalate into a more dangerous situation. Ninthly, the sensitivity of AFCI breakers can sometimes lead to confusion or frustration when they trip unexpectedly. However, it's important to remember that they are designed to err on the side of safety. Investigating the cause of the tripping is always recommended, rather than simply resetting the breaker without addressing the underlying issue. Tenthly, proper installation and maintenance of AFCI breakers are essential for their reliable operation. This includes ensuring that the breakers are correctly sized for the circuit they are protecting, that they are properly connected to the electrical panel, and that they are regularly tested to verify their functionality. In addition to the points above, it's worth noting that AFCI technology is constantly evolving. Manufacturers are continuously working to improve the performance and reliability of AFCI breakers, as well as to reduce the occurrence of nuisance tripping. Staying informed about the latest advancements in AFCI technology can help you make informed decisions about your home's electrical safety. Let's delve deeper into the technical aspects of AFCI breakers and parallel tripping. AFCI breakers utilize sophisticated electronic circuitry to analyze the waveform of the current flowing through the circuit. They are specifically designed to detect abnormal patterns that are characteristic of arc faults and ground faults. These patterns include rapid changes in current, high-frequency noise, and imbalances between the current flowing through the hot and neutral conductors. When an AFCI breaker detects one of these abnormal patterns, it triggers a trip mechanism that interrupts the flow of electricity. The trip mechanism typically involves a solenoid or other electromagnetic device that is activated by the electronic circuitry. When the solenoid is energized, it releases a latch that holds the breaker contacts closed, causing the breaker to trip. The parallel tripping feature is implemented through a communication link between the AFCI breakers on the same busbar. This link allows the breakers to share information about the current flowing through their respective circuits. When one AFCI breaker detects a ground fault, it sends a signal to the other AFCI breakers on the busbar indicating that a fault has been detected. Upon receiving this signal, the other AFCI breakers immediately trip, energizing their circuits. The communication link between the AFCI breakers can be implemented using various technologies, such as power line carrier communication or dedicated wiring. Power line carrier communication uses the existing power lines to transmit the signal between the breakers. Dedicated wiring involves installing a separate set of wires specifically for the purpose of communication. The choice of technology depends on factors such as cost, performance, and reliability. It's important to understand that the parallel tripping feature is not a substitute for proper wiring practices. It is an additional safety measure that is designed to protect against electrical fires, but it will not prevent all fires. It's still essential to ensure that all wiring is installed correctly and that all electrical equipment is properly maintained. Now, let's consider some of the factors that can contribute to nuisance tripping of AFCI breakers. Nuisance tripping occurs when an AFCI breaker trips for no apparent reason. This can be caused by a variety of factors, including faulty appliances, electrical noise on the circuit, and loose connections. Faulty appliances can generate electrical noise that can interfere with the operation of AFCI breakers. This noise can be caused by motors, electronic devices, and other appliances that draw power from the circuit. Electrical noise can also be generated by external sources, such as lightning strikes or power surges. Loose connections can create small arcs that can be detected by AFCI breakers. These arcs can be caused by corroded connections, loose screws, or damaged wiring. To minimize the risk of nuisance tripping, it's important to use high-quality appliances and electrical equipment. It's also important to ensure that all connections are tight and that all wiring is in good condition. If an AFCI breaker trips frequently, it's important to have a qualified electrician inspect the circuit to determine the cause of the tripping. The electrician can use specialized equipment to identify the source of the noise or the loose connection. In some cases, it may be necessary to replace the AFCI breaker with a more robust model that is less sensitive to noise. In addition to the factors mentioned above, it's also important to consider the age of the AFCI breaker. AFCI breakers have a limited lifespan, and they may become more prone to nuisance tripping as they age. If an AFCI breaker is more than 10 years old, it may be time to replace it. When replacing an AFCI breaker, it's important to choose a model that is compatible with the existing electrical system. The new breaker should have the same voltage and current rating as the old breaker. It should also be certified by a recognized testing laboratory such as Underwriters Laboratories or UL. Testing of AFCI breakers regularly is crucial to ensure they are functioning correctly. The test button on the breaker simulates a fault condition causing the breaker to trip if it's working properly. This test should be performed monthly to maintain optimal protection. During installation, it's also important to ensure that the neutral wiring is correct. AFCI breakers are designed to detect imbalances between the hot and neutral wires, and incorrect wiring can lead to nuisance tripping. A shared neutral, where multiple circuits share the same neutral wire, can also cause problems with AFCI breakers. Each circuit should have its own dedicated neutral wire to prevent interference and ensure proper operation. Furthermore, surge protectors can help protect AFCI breakers from damage caused by power surges and lightning strikes. These devices can absorb excess voltage and prevent it from reaching the breaker, extending its lifespan and improving its reliability. Ground fault circuit interrupters, or GFCIs, are another type of safety device that is often used in conjunction with AFCI breakers. GFCIs protect against ground faults, which can cause electric shock. They are typically installed in areas where there is a risk of water exposure, such as bathrooms and kitchens. While AFCI breakers and GFCIs both protect against electrical hazards, they work in different ways. AFCI breakers detect arc faults, which can cause fires, while GFCIs detect ground faults, which can cause electric shock. In some cases, it may be necessary to install both AFCI breakers and GFCIs to provide comprehensive electrical safety. The National Electrical Code, or NEC, provides detailed requirements for the installation of AFCI breakers and GFCIs. These requirements vary depending on the location and the type of circuit. It's important to consult the NEC and local building codes to ensure that all electrical work is performed safely and correctly. Proper grounding is also essential for the safe operation of AFCI breakers and GFCIs. The grounding system provides a path for fault current to flow back to the source, allowing the breaker or GFCI to trip and interrupt the flow of electricity. A properly grounded electrical system can help to prevent electric shock and fires. In addition to the technical aspects of AFCI breakers, it's also important to consider the human factors involved in their use. Homeowners and electricians should be properly trained on how to install, test, and maintain AFCI breakers. They should also be aware of the potential hazards associated with electricity and the importance of following safe work practices. Electrical safety is a shared responsibility. By understanding the technology and following safe work practices, we can all help to prevent electrical fires and electric shock. Another aspect to consider is the increasing use of smart AFCI breakers. These advanced devices offer additional features such as remote monitoring, fault diagnostics, and energy management capabilities. They can provide valuable insights into the electrical system and help to identify potential problems before they become serious. Smart AFCI breakers typically connect to our home's Wi-Fi network and can be controlled through a mobile app. This allows homeowners to monitor their electrical system from anywhere and receive alerts if a fault is detected. They can also remotely reset the breaker, which can be useful in situations where the breaker trips when the homeowner is away from home. Fault diagnostics is another important feature of smart AFCI breakers. These devices can analyze the nature of the fault and provide information about the potential cause. This can help electricians to quickly identify and resolve problems, saving time and money. Energy management is another benefit of smart AFCI breakers. These devices can track energy consumption and provide insights into how to reduce energy waste. They can also be used to control lighting and appliances, further reducing energy consumption. The integration of AFCI breakers with home automation systems is also becoming increasingly common. This allows homeowners to control their electrical system through a central interface, making it easier to manage and monitor their energy consumption. Home automation systems can also provide additional safety features, such as automatic shut-off of appliances in the event of a fire or other emergency. As technology continues to evolve, we can expect to see even more advancements in AFCI breaker technology. These advancements will further improve the safety, reliability, and energy efficiency of our electrical systems. Staying informed about the latest developments in AFCI technology is essential for both homeowners and electricians. By understanding the technology and following safe work practices, we can all help to create a safer and more sustainable future. The use of arc fault circuit interrupters has dramatically improved home safety since their introduction, reducing electrical fires and saving lives. By correctly utilizing AFCI technology combined with adherence to electrical codes and best practices, we significantly minimize electrical hazards in residential settings. This technology is not just about preventing fires, it is about creating a safe environment for families and protecting homes from potential electrical disasters. The continued development and implementation of AFCI breakers highlight the commitment to enhancing electrical safety and improving the quality of life for homeowners. Always consult with a qualified electrician for any electrical work and ensure that all installations meet local codes and regulations.